implicit functions differentiation. Okay, easy, just you need to understand a bit. Today we'll be doing differentiation, derivatives of implicit function. Now what do you understand by implicit function? So far the differentiation we were doing were all explicit function. What does explicit mean? English word, where the function was explicitly in the form of y. Explicitly in the form of y means, so far the differentiation we were doing, we used to have a question y equal to say cos 4x plus 2, or you had a function y equal to 3x square plus 4x, where the y was explicitly on the left hand side and you used to differentiate it. Now the type of differentiation we will get is known as implicit differentiation, where our question would be something like this. Let's see a question. Okay, the question is, find dy by dx if x minus y is equal to pi. X minus y is equal to pi. This is still easy, you just need to rearrange. So this question we can do this way: y is equal to x minus pi. Is this thing clear? And then you can differentiate both sides. You say ddx of y is equal to ddx of x minus pi, or you say dy by dx is equal to ddx of x is how much beta? 1. And what is about pi? This is 0. So dy by dx is equal to 1. Pretty easy, this example. Let's get into a little bit, but you hardly will get a question like this. Okay, so let's get into some more questions and let's understand them. Right, our next question is, differentiate dy by dx, that is, sorry, not differentiate, find dy by dx if, and our equation given is y plus sine y equal to cos y plus sine y is equal to cos x. Okay, now we have a problem. Y plus sine y equal to cos x. Now see, now the y you cannot take separately. If you take y separately also, you will have a sine y term already there, right? How to do this problem? So what do? We first write our solution would be, and your knowledge of chain rule will also be used, is equal to cos x. Did you understand this step? Same thing. Now we write differentiating both sides. Differentiating both sides with respect to x. Differentiate both sides with respect to x. What do I write? I write, I'm doing baby steps so that you understand. Y plus sine y is equal to ddx of cos x. Tell me, children, have you understood this much? Absolutely baby steps, okay? And as you are understanding this, I am reducing the size of this one so that I can use this space. Okay. Further, baby steps. ddx of y plus ddx of sine y is equal to how much? ddx of cos x. Clear? No issues so far? ddx of y is dy by dx, and this is what you have to find out. Now here we start using chain rule. So what do? We do it dy into sine y into dy by dx. Have you understood this step? We did chain, right? And this becomes equals to negative sine x. Clear, bacha? Okay. So Now we have dy by dx, right? Plus, if you look into the bracket, what do we have in the bracket? Okay, we don't need the bracket. We'll just open the bracket. We have a cos y, then into dy by dx is equal to minus sin y. Now take dy by dx common. It is 1 plus cos y is equal to sin x. Sorry. Is equal to, sorry, bacha, this is sin x. This is equal to minus sin x. Minus sin x. Or dy by dx is equal to minus sin x by plus cos y. Our problem is done. Finally, you have to get a dy by dx. Just check whether you have understood or not. Okay. Now, in these questions, this we need, generally it is better you put a condition. What is the condition? Let's see what the condition. We cannot have the denominator as 0. We cannot have the denominator as 0. So if cos y is equal to negative 1, that means y should be equal to 2n plus 1 times of pi. Just see, every odd multiple of pi, cos becomes negative 1 pi, where n is equal to 0, 1, 2 and so on. Therefore you should write here that this is valid where y is not equal to 2n plus 1 pi, where n 2n plus 1 pi, okay, where n is equal to 0, 1, 2. Otherwise your expression will not hold correct. Clear? Chalo. Let's see some problems from your exercise. We are at exercise 5.3. Exercise 5.3. Question number 1. In everything we have to find dy by dx. 2x plus 3y is equal to sin x. We have to find dy by dx. So first step is what? Differentiating both sides. Differentiating both sides with respect to x. So what do you get? You write ddx of 2x plus 3y is equal to ddx of sin x. Right, Neha, if you have your book, just open, keep the answer script also page ready if you have. So this becomes ddx of 2x is 2, and this will become ddy of 3y into dy by dx, and this is equal to cos x. So it becomes 2 plus 3 dy by dx is equal to cos x. Sir, yes, sir.
In the beginning, would we rearrange the equation to like have a dy on the left?
You can do that. Still, you will get the same answer.
Okay.
You will get the same answer. We'll do that also. So dy by dx is equal to cos x minus 2 whole thing divided by 3. Okay, bacha? Let's do by the way you suggested. Let's do by the way you suggested, okay? Y is equal to sin x minus 2x upon 3. Okay? डी डी एक्स ऑफ साइन एक्स इज बेटा कॉस एक्स एंड डी डी एक्स ऑफ 2x इज 2. Clear? No issues. Always when such thoughts comes ना नेहा, challenge yourself और करो उसको भी, देखो सेम आ रहा है कि नहीं. Okay, let's do the next one. Next one you guys do. It's the same type. Now here you cannot separate like the way you were saying separation कर लेंगे, यहां separate नहीं कर पाओगे, यहां फंस गए आप. Clear? So what do? We differentiate both sides. So let's see that. Keep just your eyes fed so that you are not differentiating any y variable with respect to x. देखो तो able to do, ठीक है. Shall we pick another one now? चलो, let's do one more. ax plus by square is equal to cos y. Now d dy of by square, b is a constant, so b comes here, 2by into dy by dx is equal to negative sin y dy by dx, or dy by dx 2by plus sin y is equal to negative a, or dy by dx is equal to negative a upon 2by negative a upon, देखो बच्चा खुद कीजिए. ठीक है, मैचिंग. Shall we take one more? चलिए एक और करते हैं. xy plus y square equal to tan of x plus y. Tan of x plus y. ठीक है? Differentiating both sides with respect to x. Right? So you get a ddx of xy plus y square is equal to ddx of tan x plus y. Now we need to be careful. Look, it is xy. It is xy. So here, first product rule will be applicable. So let's make it more baby steps. This is ddx of xy plus ddy of y square multiplied by dy by dx is equal to ddx of tan x, which is sec square x plus dy by dx. ठीक है? अब इसको ब्रेक करते हैं. आ जाओ. First function into differential of second function plus second function into ddx of x, which is 1. ddx of x is 1. Did you understand this step or not? First function into differential of second plus second into differential of first. ठीक है? Here what do we get? Here we get 2y into dy by dx is equal to sec square x plus dy by dx. So it's our cleaning time now. So how do we clean it? We take dy by dx common. We have a x, we have a plus 2y. Okay, then we have a minus 1. This dy by dx comes this side. So you get a sec square x minus y. This y goes that side. ठीक है? So dy by dx will be equal to sec square x minus y divided by x plus 2y minus 1. Is this understood? Okay. चलिए और एक करते हैं. Our next problem is x square xy y square. X square xy. Can you give a try? आप try करो. So we have x for product rule and we have a power function also. So we differentiate both sides with respect to x. Step jump मत कीजिए. Step jump करेंगे confusion हो जाएगा. Differentiating both sides with respect to x. Right? So let's differentiate ddx of x square plus xy plus y square is equal to ddx of 100. Right? This is further ddx of x square plus ddx of xy plus ddx of y square is equal to 0. 100's differentiation will be 0 because 100 is a constant. ddx of x square is what, beta? 2x. Here again, product and this function x dy by dx plus y into 1 plus ddy y square into dy by dx is equal to 0. Further, 2x plus x dy by dx plus y plus 2y dy by dx equal to 0. Time for us to take common dy by dx x plus 2y is equal to minus 2x minus y. Minus 2x and minus y. So dy by dx becomes equals to negative common 2x plus y divided by x plus 2. Check कीजिए. Do on your own and keep checking the steps. Done. Let's check one more. Our next question is x cubed x square y, x cubed x square y, x cubed x square y, xy square y cube, xy square plus y cube, which is equal to 81. Which is equal to 81. So let's do it. Respect to x. Fine. Whenever it is easy, we'll go easy way. ddx of x cube is 3x square. Now here we have to apply chain rule. First function into dy by dx plus second function into ddx of first function. देखो तो ये step समझ में आया कि नहीं? Did you understand this? First function differentiation of second plus second differentiation of first. ठीक है? Similarly, we have to do it in the second one also. First function into differentiation. Okay, here it is interesting. Children, you have to differentiate y square. I am just omitting baby steps. Let me see you understand or not. Y square you are differentiating with respect to y, so it should be 2y into dy by dx. Did you understand this? First function into ddx of y square. ddx of y square is ddy of y square into dy by dx. ddy of dy square plus second function into ddx of first function plus again I have to differentiate y cube. Y cube would be what beta? Y cube would be 3y square dy by dx. देखो तो ये समझ में आया कि नहीं? Clear? Things are getting into, animal is now tamed a little bit. So this is 3x square plus x square dy by dx plus 2xy plus 2xy dy by dx. Okay. Plus y square plus 3y square dy by dx equal to 0. Further tells me if I take dy by dx common, I have got an x square, I have got a 2xy, and I have a 3y square. On the other side, what do I have, children? I take a negative common, it's a 3x square minus 2, so plus 2xy, right? 3x square, 2xy, and this plus y square. So my dy by dx becomes equals to did it match? Okay. Okay. Our next one. Seventh problem. Sin square y plus cos xy. Sin square y plus cos xy. Sin square y plus cos xy is equal to k, or this is like kappa k. Chaliye, let's do. Differentiating both sides with respect to x, you get d dx of so here we went wrong. So this is that was what was my doubt. Now it will come okay. You know what went wrong? You can't differentiate like this. This is d sine y into sine square y into d of sine y by dy into dy by dx. It's a power. That's where I was stuck up there also. Okay. This will give you minus sine xy into dy by dx. Okay. And plus y into 1. Here also we made a mistake. We didn't multiply that. Okay. So let's check this up. This is 2 sine y. Then this is cos y. And then this is dy by dx. Minus, we get what? We get x sine xy dy by dx minus y sine xy is equal to 0. Clear? X sine xy and y sine. This is sine 2y. 2 sine theta cos theta is sine 2 theta dy by dx minus x sin xy dy by dx is equal to y sin xy. So yeah, which means dy by dx, it is sin 2y minus x sin xy, yeah, is equal to y sin xy, or dy by dx is equal to y sin xy sin 2y. देखो तो बेटा अभी मैच किया है क्या?
Yeah,
ठीक है ना? You should have is patience. ठीक है? The last of this series in your book, which is question number 8, sin square x plus cos square y is equal to 1. Sin square x plus cos square y is equal to 1. Right? So we do differentiating both sides with respect to x. So you have a ddx of a sin square x plus cos square y, which is equal to 1. Oh, sorry, not 1, ddx of 1. So this will be d sin x into sin square x multiplied by d sin x by dx plus ddx of cos square y is equal to 0. This becomes 2 sin x and this is cos x plus this is a d cos y cos square y into d cos y dy into dy dx is equal to 0. This becomes sin 2x, and here we get something that is a minus. Why minus? I'll tell you. This becomes 2 cos y, and ddx of cos y is minus sin y, so the minus y into dy by dx is equal to 0. Right? So this is sin 2x minus again 2 sin 2y. It's not 2 sin 2y, sin 2y. This is sin 2y dy by dx is equal to 0, or dy by dx is equal to negative sin 2x divided by negative sin 2y. Check. Okay. These were the implicit functions which were there in your book. The question is, how do you identify? Looking at the function itself, you will identify, because y will not be separate. Our next type of differentiation, maybe we'll do only 1 or 2, others which will be too much information processing today. The next type of differentiation we have is inverse trigonometric differentiation. So let's keep your formula sheet ready with you. ddx of sine inverse x is 1 by root over 1 minus x square. Cos x is minus 1 by root over 1 root under 1 minus x square. Tan x is 1 by 1 plus x square. Cot x is minus 1 by 1 plus x square. And sec x tan x will have minus 1 x mod x x root over 1 minus x square 1 plus x square. Okay, so let's take one problem. Okay, here you need to have a lot of judgment actually, otherwise you will not be able to solve. This is initially children find it a little bit difficult. Sine inverse 1 by 1 plus x square. Sine inverse 1 by 2x by 1 plus x square. Now look children, how to do this problem? You first identify what is in an inverse, you identify what is inside. That inside you try to see it is differential of some trigonometric function. If you look at 1 plus x square, 1 plus x square comes in the differentiation of tan inverse x. See, if y is equal to tan inverse x, then dy by, I'll just show one problem, we'll do it in next class, don't worry. This is the differential. If you see your formula page, now this is matching with the argument of the function. So here x we will take as tan theta. We will take x as tan theta, जिसका inverse है, उसका theta लेंगे. Let x be equal to tan theta. Clear बच्चा? Okay. So what does y become? Y becomes sine inverse, what is it? 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta. Is it clear? This is y is equal to sine inverse sine 2 theta. Sine 2 theta is 2 tan theta by 1 plus tan square theta. ये सब थोड़ा याद रहना पड़ेगा. Sine 2 theta formula in terms of tan theta. Here we can straight away now say y is equal to 2 theta. Sine inverse of sine 2 theta is 2 theta. Now resubstitute y is equal to how much? So here we say theta is equal to tan inverse x. So 2 tan inverse x. Now you are differentiating. dy by dx equal to 2 into 1 by 1 plus x square. Did you understand this? I jumped one step. If you want it, it's like this. dy by dx is equal to ddx of 2 tan inverse x, which is 1 by 1. In our next class, you can go to any AI or any book and do a lot of implicit functions today. Do some implicit functions, and in our next class, what we will do, we will be carrying out problems of inverse differentiation. After that, we will have logarithmic differentiation, and then the chapter will end and we will go into application of derivatives. इसमें आपको ये अंदर देखना पड़ेगा किसके साथ मैच करता है. If anything is 1 plus x square, close your eyes and make it, let x be equal to tan theta. 100% it will match out. ठीक है? Close today then, otherwise it will be too much. Do some more implicit functions. If you want, I can do, but ये मजा नहीं आएगा. आप, you can do one problem. One more you can do. Y equal to cos inverse. We can do this problem. Y equal to cos inverse 2x by 1 plus x square. Is it? Y equal to cos inverse 2x by 1 plus x square. Again, this is of tan theta format. So what do we say? Let x be equal to tan theta. So your y becomes cos inverse 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta. Now see what is the formula of cos 2 theta. Okay. Cross check yourself with cos 2x. Cos 2x is 1 minus tan square x. क्या ये तो मैच नहीं कर रहा है, अब क्या करेंगे? How to do this? So let's see. What can we write for this? This is sin 2x. Clear? So we can write y is equal to cos inverse cos cos 90 minus theta is sin theta. Cos 90 minus theta is sin theta. Clear ना? ठीक है, अब इसको क्या लिख सकते हैं? These you can say this is equal to this only in that principal range. You should also say what is the principal range, though nobody checks. So now you can do dy by dx, which is equal to, oh sorry, थोड़ा सा गलती हो गया, So this is sin 2 theta minus 2 theta. So pi by 2 minus 2 theta, which is equal to pi by 2 minus 2 tan inverse x. Here we write theta is equal to tan inverse x. हो गया ना? अब easy हो गया problem. So dy by dx will become what beta? dy by dx will become 0 minus 2 into 1 by 1 plus x square. Check the answer once. It is question number 13. Matches? Yeah. And question number 9, you just check the answer, the one we just did. ठीक है, चलो बाकी अगले क्लास में करेंगे.